Hey guys, welcome to our next tutorial, Hashtable. So this is very interesting topic. So Hashtable is using the data structure which is underline is hash table only. Okay. So in the hash table, insertion order is not preserved and it is based on hash code of keys. Alright, third point is duplicate keys are not allowed and values can be duplicated. So in hash code, duplicate keys are not allowed, but the values can be duplicated. Heterogeneous objects are allowed for both keys and values in hash table. Means you can have any type of objects into as a key or values. Fifth point is null is not allowed for both keys and values. Otherwise, you will get runtime exception saying null pointer exception. So fifth point says null is not allowed either in keys or values. Sixth point is it's implement serializable and clonable interfaces but no random access. All right, so this is very important part. So if it has implemented random access interface as well, then the insertion become very fast. I'll explain this in later tutorials, but for now just remember it implements serializable and clonable interfaces but no random access interface. Seventh point is every method present in hash table is synchronized and hash table object is thread safe. So every method in the hash table is synchronized and because of that it is thread safe. Eighth point is hash table is best choice if our frequent operation is search operation. Okay, so in the hash table the default capacity is 11. All right, so if I say here, if I have written new hash table, and if you can see this is the default constructor, the initial capacity of this hash table is 11 and the fill ratio is 0.75. Okay, the map and the set initial capacity was 16 and hash table initial capacity is 11. Okay, all right, now let's see one simple example. I have created a hash table and then I put 6 values into it. And what are those values? I created a class temp where I define I variable. This temp is the constructor which is returning this I value, and here is our hash code. Okay, public int hash code which returns I, and returning I is actually helped by toString method. Okay, so public string to string method, I say return I plus double quote, so it will become a string. Because it is int, we need to actually return it as a string, because hash code is returning value using toString method. Okay, now what I'm saying in the hash table object, I'm putting new temp5 which value has a, then 2, 6, 15, 23 and 16. So here I'm passing 5 value in the constructor, here I'm passing the 5 value. Okay, in the hash code it will return like as a 5. Okay, so 5 to 16, 15, 23 and 16. When I run this program I'll get this result. Okay, when I'm printing this h, so 6c, so this is the 6c print first, 16f, 5a, 15d, 2b and 23e. Now it is very important to understand how this will print. So let me show you one example of that. So here I show you, like, for the initial capacity of hash table is 11. So suppose in the internal memory what we do, we create a table of 11, 0, assume it is still 11. Okay, now for the first one we are saying new temp5 has value a. So this is placed at fifth position. Okay, so if you see at fifth position we have phi equal to a. Okay, now second one is new temp2 equal to b. So at second position we have 2b, 6c. So at sixth position we have 6 equal to c in this memory. Now we have 15th d. Okay, now whenever we have a value greater than 11, means because the initial capacity is 11, so what we do, we'll do 15 modulus 11. Okay, so the remainder is what, where we put this value. So remainder is 4 here. Okay, so 4, I put 15 equal to d. So basically we divide this by 11. So whatever is the remainder, we will have this particular location to put this value. I hope you understand. Now next is 23e. So if I divide 23 by 11, then I'll get 1 as a reminder. So at first position we need to put 23 equal to e. So at first position we are putting 23 equal to e. And similarly 16f, so 5 is the remainder. If if I'll divide it by 11, because 11 is the initial capacity, so 5 at fifth position we need to put 16 equal to f. So we have already 5 equal to here, so we will put by making separated by comma 16 equal to f here. So now how hash table is actually print? The approach is from top to bottom and right to left. I repeat, from top to bottom and right to left. So first it will print 6c, then 16f, 5a, 15d, 2b, and 23e. So if you see here 6c, then 16f, 5a, 5a, 15d, 2b, and 23e. All right. So this is how we print. So now suppose if I pass 25 here, okay, as an initial capacity, now the output will change. You see here, this output is now changed because now 23e will print, because it it has a block in the table for 23 as well, because now the initial capacity is 25. So we have till 24, 0 to 24. So it has a 23 block, okay, in the table. So it will first print 23e. It has the 16 block as well, 16f, 15d, 6c, 5a, and 2b. Okay, I hope you have understand this. So about the constructor, so we have three more constructor. So first was the default, second one we can pass initial capacity, third we can pass initial capacity and fill ratio. So here like fill ratio. Okay, okay, we'll pass it other way, never mind. And the third one is we can pass a map, a full map. So this is all about hash table. So you can understand now how we can print a hash table and how memories actually work. Thank you.